Well, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, class.
Morning, Mister.
Okay, how are you today?
We are fine. What about you, Mister?
Okay, I'm fine too, thank you. Well, before we start the lesson of the day, let's say a prayer together. Prayer begin. Finish. Okay, student, I have shared to you the proof of attendance link in Google Classroom. So I give you 3 minutes for filling in it. Go. Well, have you felt it?
Yes, we are ready, Mister.
Okay, let's start our lesson. Don't forget to prepare your learning equipment first. My window. Okay, are you ready?
Ready, sir?
Okay, nice. Please wait. Anyway, do you remember what the material we studied last time? So, what's the material? What did we talk about last time?
Yes, last time we talked about oxides.
Yes, about oxides. So today we are going to talk about preparation of salt. So I have shared to you the worksheet in WhatsApp group. You can fill in it during the lesson and you must collect assignment in WhatsApp group after this class. Before that, you can read the instruction first to make it easier to do.
Okay, Mister. Thank you.
Yes. Okay, please wait. Well, our topic of the day is preparation of salt. So, at the end of this lesson, you will be able to describe the preparation of insoluble salts by precipitation, and then describe the general solubility rule for salts. There are some points that you must to understand, and then the third, define a hydrate substance as a substance that is chemically combined with water and anhydrous substance containing no water. Okay, look at this picture. So, what are this picture?
Picture. Salt.
There's a picture of salt, Mister.
Yes, of course. That's right. These are salt pictures. So, sorry. So, what do you think about what are characteristics of salt? So I give you opportunity to convey your overview about the picture. Please raise your hand before that.
I want to give an answer, Mister.
Yes, please, Rosiani.
Salt has a salty taste, Mister.
What? Can you reply?
Salt says as a salty taste, Mister.
Yes. Nice. So, is there any another answer?
No, Mister.
No,
Oh,
Mister.
just Rosiani. Okay, well, doesn't matter. But I have a question for you. Have you ever paid attention to the salt that is put into food when you are cooking? Will it dissolve or not?
Yes, mister. Salt will dissolve when we put in the food, especially in soup. Mmm, yummy.
Yes, so yummy, yes, Patrida. So, why did it happen? Hello? Any response? Yes, okay. Well, if no answer, so I will describe to you. So please your attention. Okay, slide. So before that, I wanna ask to you, what is salt? Move on to answer.
I want to answer, Mister.
Yes, please, window.
According me, salt is the one of ingredient that added to food to make food salty.
Yes, only that.
Yes, Mister. Only that.
Okay, good. Thank you, window. Yes, okay, not bad, but I think there is a better answer. So, is there another answer? How about you, Patrida?
My answer is the same as window answer, mister.
Oh, yes. Okay, no problem. So, if no another answer, I will continue the lesson this way. So, this is the definition of salt. So, salt is an ionic compound which is made up of two groups of oxidely charged ions. The ion with a positive charge is called cation, and the one with a negative charge is called an anion. Usually, salts consist of positive ions from a metal with negative ions from a non-metal. So, another definition of salt is the substance produced by the reaction of an acid with a base. A salt consists of the positive ion or cation of a base and the negative ion or anion of an acid. The reaction between an acid and a base is called a neutralization reaction. The term salt is also used to refer specifically to common table salt or sodium chloride. Okay, next material is salt. So salt consists of two types, namely soluble salts and insoluble salts. Okay, Ingrid, can you read the PowerPoint slide?
Yes, Mister. Salts two type. One soluble salt are ionic compounds that are solute in water, and two insoluble salt are ionic compounds that are insoluble in water.
Okay, thank you, Ingrid. So the salt is consists of two types, namely soluble salts and insoluble salts. Okay, okay. The next. So to know the solubility of salt, we must first know the factors of solubility. So the first one, the effect of ion charge insolubility. Compounds of ion with small charge tend to be soluble. Compounds of ion with large charge tend to be insoluble. Why? Increasing the charge increases the force that holds the ion together. For example, phosphate tend to be insoluble. On the other hand, the salt of alkali metals are soluble. Alkali metal cations have a single positive charge, so the force that holds the ions together is less. So, and then the second is the effect of ion size on solubility. When an atom gives up or gains an electron, the size of the ion that results is different. from the size of the original atom. And then so you can look at the picture. You can see that the sodium ion is smaller than the sodium atom. Okay, you can see that. And then in general, the ions of metal tend to be smaller than their corresponding neutral atom. For the ions of nonmetal, the reverse is true. The ions of nonmetals tend to be larger than their corresponding neutral atom. You can see that there is a chloride atom and chloride ion. Then, thus, the bond between small ions is stronger than the bond between large ions with the same charge. As a result, compounds with small ions tend to be less soluble than compounds with large ions. Consider the ions of elements from group 7A, for example. Remember that the size of the ions increase as you go down a family in the periodic table. Therefore, you will expect the fluoride compounds are less soluble than fluoride, bromide, and iodide compounds. That tends to be the case. Okay, so are you with me, class?
Yes, Mister.
Yes, Mister.
Yes, Mister.
Well, let's continue our lesson. So, precipitation. So, in chemistry, a salt can be produced in a reaction called the precipitation reaction. So, what is precipitation?
I want to answer, Mister.
Okay, please, Patrida.
A double displacement reaction that results in the formation of an insoluble substance is often called a preparation reaction.
Okay,
Done.
thank you, Patrida. So, the precipitation reaction is a double displacement reaction that results in the formation of an insoluble substance. Okay, and then the reaction has the general equation that you can see in PowerPoint template. This is the general equation of precipitation reaction. So I think you have understood that because you have ever studied it before. Okay, there is an example. Now, this is an example of the precipitation reaction which involves the substance, namely lead nitrate and potassium iodide. So, lead nitrate and potassium iodide are clear, colorless aqueous solution. Mixing them causes a double displacement reaction. An insoluble yellow precipitate, lead or lead iodide, and a soluble salt or potassium nitrate are produced. So this is the reaction. This is the lead nitrate compound, and this is potassium iodide compound. So if they are got reaction, so they will produce the yellow precipitate, namely lead iodide and the potassium nitrate substance. Okay, for increasing your understanding, so let's watch the video.
In the double displacement reaction of lead nitrate and potassium iodide, we have a colorless solution of lead nitrate. We'll add a colorless solution of potassium iodide. As the potassium iodide reacts with the lead nitrate, we get the formation of a bright yellow solid, which is lead iodide.
Okay, that video shows us about the reaction of the lead nitrate and potassium iodide. So after their reaction, so the product is the yellow precipitate. And then the next one is general solubility rule of salt for salts. So from the material, any question before?
No, sir.
No
No?
questions, sir.
Yes. Okay. And the next one is general solubility rule for salts. Oh. So many factors affect solubility. Thus, predicting solubility is neither straightforward nor simple. So the properties of the ions that make up a compound greatly affect the solubility of a compound. But in some cases, there is a discrepancy. For example, an ion can cause a compound to dissolve if it combines with certain ions, so that it doesn't produce a precipitate. But in other cases, this ion can cause a compound to dissolve if they combine with other ions. So, from there, by performing experiments, chemists have developed guidelines to help them make prediction about solubility. And now we know that as general solubility rule for salt. So general solubility rules are a collection of solubility generalization based on experiment, which is summary of ionic compound interaction with water. When a salt solution is mixed with each other, the ions may dissolve, which is no reaction between ions, but several forces that affects solubility, namely, the first one is the attractive force between water molecules and solid ions. This force tends to bring the ions into solution. If the force is relatively large, the compound will dissolve more in water. And then the second one is the attractive force between the ions with opposite charge. This force causes the ion to remain in a solid state. When this force is large, the solubility will be very small. Okay, this is the sum of the general solubility rule for salt. So, Windu, do you want to read it? Please read the PowerPoint slide. Windu, can you hear me? Oh, if Windu can, Patrida, can you read it?
Yes, Mister. General solubility rule for salt. Sodium, potassium, and ammonium salt are soluble. Nitrate are soluble. Chloride are soluble except lead and silver. Sulfate are soluble except barium, calcium, and lead. Next, carbonates are insoluble except sodium, potassium, and ammonium. And then hydroxides are insoluble except sodium, potassium, ammonium, and calcium. Done, Mister?
Okay, thank you, Patrida. So, this is the solubility rules chart. This is the function of this is to easier us to determine about the characteristic of solubility of salt. So, and how to read it? You can look up ions in the solubility chart. You might find this easier. Cations are listed across the top. So this is the cations, and then anions are listed vertically. So this is the anion. And then find the cell where your cation, column, and iron row meet to determine solubility of the resolving compound. So, for example, we can, if we determine the characteristic of the solubility of sodium chloride, and so how to do it? The first one, we should find the sodium column, and this is here. And then I'm sorry, the first one is we should determine the ion of the sodium chloride first. So sodium chloride is content of a sodium ion and chloride ion. So and then we find the position of the each of ion, which is the sodium is here and the chloride is here. So we can take a line, white, sorry, which is where is the pencil? Who knows? Where is the pencil? Sorry. Oh no. Please white, guys. It's white student. Sorry. Okay. Yes. So after we found the position of each the ions, and then we can take the line. This is the line of a chloride. Yes, and then this is the sodium line. So we can determine the characteristic of the solubility of sodium chloride is soluble. Yes. Do you understand? Okay,
Understand, Mister?
like that. Okay. And then, then this is the other general solubility guidelines. So you can read it. Some of general solubility guidelines. Okay. The next material is substance. Okay, before that, I wanna ask to you, do you still remember what is the substance?
Yes, I do, Mister. Let me answer.
Yes.
Substance is something that has mass and occupies space because it has volume, Mister.
Yes, excellent. Thank you, Windu. So, what Windu said is correct. That substance is something that has mass and occupies space because it has volume. Then, substance are of two types, namely hydrate substance and anhydrous substance. For definition, Rosiani, please read the PowerPoint.
Yes, Mister. Substance. Hydrate substance or anhydrous substance. Hydrate substance is substance that spontaneously absorbs water from the air to form hydrate, or known as hygroscopic or diluent. Anhydrous substance is hydrous that loose so called water of hydration or water of crystallization to form the anhydrous substance.
Okay. Okay, are you understand, student? Any question? Okay. No, this is a video. So let's watch this video for increasing your understanding.
Look at the beauty of these hydrous crystals. You see copper sulfate or blue vitriol, ferrous sulfate or green vitriol, decahydrate or washing soda. These beautiful colors and shapes is because of the water of crystallization. Water of crystallization is the amount of water necessary to maintain the crystalline properties of certain metallic compounds. This is responsible for the geometric shape and the color of crystals. This water can be expelled by heating. Do you wonder what will happen if we remove the water of crystallization by heating? We shall try it out with some crystals of copper sulfate. Take some copper sulfate crystals, a spirit lamp, test tube, beaker filled with water, petri dish. Take some crystals of copper sulfate in a test tube. Now put the test tube on the flame and wait till we expel the water from the crystal. Be patient. Observe water vapors coming out of the hot copper sulfate crystals. Also notice the beautiful blue crystals turning white. Let the anhydrous white powder of copper sulfate cool. Take a pinch of it and feel. It feels dry and powdery. Now add a few drops of water to this anhydrous salt. The salt regains its color and crystalline form. It is blue once again. A substance containing water of crystallization is called a hydrous substance or a hydrate. This water can be expelled by heating, and then the salt is said to have become anhydrous. Remember, certain substances like sodium chloride or common salt do not require the help of water to form their crystalline shape. Can you find out more such crystals which do not need water? And you should know how.
Okay. How about this video? Are you understand, student? Hello? Are you understand?
Understand,
Yes,
Mister.
Okay. Okay, because the time is almost up, so let we move the new room. I will share the link to you. Okay, see you in the next room. Okay, thank you so much, class, for you are still joining with me in the lesson. So let's continue our lesson. This white, I will share the PowerPoint slide. This white. Okay, continue. Well, this is the end of the slide. So, well, I think that's all of our material today. So until now, do you have any question? Do you any question, us?
No,
No,
Mister.
no, Mister.
Okay, good. If no question, I will ask to you. So, how many types of substance and what that substance consists of?
Let me answer, Mister.
Yes, please, Ingrid.
The substance consists of two types, namely hydrate substance and anhydrous substance. Which are the hydrate substance is the substance contain water, and the anhydrous substance is the substance contained on the water.
Yes, right. Excellent. Thank you, Ingrid.
You're welcome, sir.
Okay, Kalas, have you finished your worksheet?
Yes, Mister.
Yes, I have Mister.
Patrida, how about you?
Yes, I have Mister.
Okay, good. So if you have finished your worksheet, we discuss about that. So before that, where is Ingrid?
Sorry, Mister. Ingrid can join because the signal at her house is not stable.
Okay, no problem. Thank you, Windu. Okay, we start to discuss our worksheet. So before that, please read the question first and then give your answer directly. So please fight. Okay, who wants answer the number one and number two?
I, Mister.
Yes, please, Patrida.
Number one, salt is an ionic compound which is made up of two groups of oppositely charged ions. There are cation is from a metals and anion is from a non-metals.
Okay, number one, salt is an ionic compound which is made up of two groups of oppositely charged ion. There are cation is from a metal and an ion is from a non-metal. Okay, next, number two.
Number two, salt consists of soluble salts and insoluble salts, Mister.
Okay, number two, salts consist of soluble salts and insoluble salts. Okay, thank you, Patrida. Okay, who wants answer number three and number four?
I, Mister.
Okay, please, Rosie.
Number three, bang are ionic compounds that are soluble in water. Bang are ionic compounds that are insoluble in water. Uh, Soluble salt are ionic compounds that are soluble in water. And insoluble salt are ionic compounds that are insoluble in water.
Okay, number three. Soluble salts are ionic compounds that are soluble in water, and insoluble salts are ionic compounds that are insoluble in water. Okay, good, Rosiani. Next, number four.
Number four, the factors of solubility, namely the effects of ion charge on solubility. Compounds of ions with small charge tend to be soluble. Point B, the effects of ion size on solubility. When an atom gives up of against an electron, the size of the ion that result is different from the size of the original atoms, and then the small ion bonds more closely together than large ions.
Okay, number four. The factors of solubility, namely point A, the effects of ion charge on solubility. compounds of ions with small charge tend to be soluble. And point B, the effect of ion size on solubility. When an atom gives up or gains an electron, the size of the ion that dissolves is different from the size of the original atom. And then the small ions bond more closely together than large ion. Okay, thank you, Rosie. Okay, who wants to answer number 5 and number 6?
I want to try to answer the question, Mister.
Okay, please, Windu.
Okay, thank you, Mister. For number 5, the question is a double displacement reaction that result in the formation of an insoluble substance is often called blah blah blah. And my answer is a precipitation reaction, Mister.
Okay, number 5. A double displacement reaction that results in the formation of an insoluble substance is often called a... Yes, that's right, precipitation reaction. Okay, number 6. Next.
Okay, Mister. For number 6, the question is general equation of precipitation reaction is for the answer. May I write on the screen, Mister?
Okay, please, Windu. Time is yours.
Okay. Okay, wait, Mister. The pen. Can you see on the screen, Mister?
Yes, we can see.
Okay. Wait. For number 6, the question is, sorry, Mister.
Yes, okay, no problem.
Double X compound, yeah, will react with with y z. Nah, y z. Sorry, Mister. Nah, compound react with y z compound. Nah, becomes um w z and it's so difficult, and becomes to y x y e y x compound, Mister.
Okay.
It's my answer.
Okay, good, Windu. Okay, number 6. General equation of precipitation reaction is... Yes. For example, is if the WX compounds reacts with YZ compounds will become WZ compounds and YX compound. Yes. So your answer is good. Okay, thank you, Windu. Okay. Windu, can you, yes, delete your answer before clear your screen. Okay. Okay, the next number 7 and 8. So who want answer number 7 and 8?
I'm Mister.
Okay, please, Patrida.
Okay, thank you, Mister. So for number 7, lead to nitrate and potassium iode are clear. Colors solutions. Missing them causes a double and a soluble salt potassium can the reaction changes. Okay, and my answer is so. If lead nitrate reacts with potassium iodide, they will produce.
Your signal is not good, Patrida. So, where is Patrida? Oh,
I'm sorry, Mister.
yes, no problem. Okay, would you reply your answer, please? Patrida, can you hear me? Okay, no problem. So, I will answer the number 7. Okay, number 7. Lead nitrate and potassium iodide are clear, colorless, aqueous solution. Mixing them causes a double displacement reaction. An insoluble yellow precipitate or lead iodide and a soluble salt, potassium nitrate, are produced. Write down the reaction equilibrium of their mixture. So the answer is if the lead nitrate reacts with potassium iodide, so will produce the yellow precipitate, namely lead iodide, and the soluble salt, potassium iodide. So this is uh, the the compounds. You can see that on the screen. Okay, number 8. Can you continue your answer, Fatrida? Fatrida? Fatrida, can you hear me? Okay, if you can continue the answer, so I will continue that. Okay, number 8. General solubility rules are blank, blank, blank. So the answer is general solubility rules are collection of solubility generalizations based on experiments, which is summary of ionic compound interactions with water. Okay, how about your answer, class? Are you right or false? Is
My
your
answer is
answer
right,
is
Mister.
true? Is true or false?
My answer is true, Mister.
Okay, true. Okay, next, who wants answer number 9 and 10?
I, Mister.
Okay, please proceed.
Number 9, sorry. Several forces that affect solubility, namely, my answer, point A, the attractive force between water molecules and solid ions. Point B, the attractive force between the ions or the ions with opposite charge.
Okay, number 9. Several forces that affect solubility, namely, point A, destructive force between water molecules and solid ions, and B, destructive force between the ions with opposite charge. Okay, thank you, Rosiani. Okay, next.
Okay, number 10. Some of general solubility rules of salts, namely, point A, sodium, potassium, and ammonium salt are blank, blank, blank. My answer, soluble. Next, point B, nitrates are my answer, soluble. Point C, chlorides are soluble, except my answer, lead and silver. Point D, sulfates are soluble, except barium, calcium, and lead. Point E, carbonate are insoluble, except my answer, sodium, potassium, and ammonium. And point F, hydroxide are blank, 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 except sodium, potassium, ammonium, and calcium. My answer, insoluble.
Okay, number 10. Some of general solubility rules of salts, namely A, sodium, potassium, and ammonium salt are, yes, soluble. And then B, nitrates are, yes, soluble. And C, chlorides are soluble except lead and silver. Okay. And then D, sulfates are soluble except barium, calcium, and lead. Okay. E, carbonates are insoluble except sodium, potassium, and ammonium. Okay. And then F, hydroxide are insoluble except sodium, potassium, ammonium, and calcium partially. Okay, good, Rosie. Okay, the last number, number 11. Who wants answer?
I am Mr.
Okay, please, Windu.
But before, I'm sorry if my question is not true, Mr.
Okay, no problem.
Okay, for number 11, the question is substance consists of hydrated and anhydrous substance. For point A, hydrated substance is blah blah blah, and point B, anhydrous substance is blah blah blah. And my question for point A, hydrated substance is a substance that spontaneously absorb water from the air to form hydrates are known as hygroscopic or deliquescent. And for point B, anhydrous substance is hydrates that lose so-called water of hydration of water of crystallization to form the anhydrous substances. Is my answer, Mr.
Okay, thank you, Windu. Well, number 11. Substance consists of A, hydrate substance, and B, anhydrous substance. So, hydrate substance is substance that spontaneously absorb water from the air to form hydrates are known as a hygroscopic or deliquescence. And B, an anhydrous substance is hydrates that lose so-called water of hydration or water of crystallization to form the anhydrous substance. Okay, good, Windu.
Thank you, Mr.
Yes, you are welcome. Before I end this class, are you sure that you have no question?
No, mister, we have understood about today's lesson.
No, Mr.
Okay. Okay. If no question, I want one of you convey the conclusion about our lesson today. Who wants to do?
I want to do, Mr.
Yes, please, Windu.
Okay, Mr. Thank you. Well, today we studied about salt, which is salt has two types, namely soluble salt and insoluble salt. But focus our lesson today is about insoluble salt. And insoluble salt forms from the reaction called the precipitation. Now, to make it easier to determine whether a salt will dissolve or not, it can be determined through the general solubility rule for salt. And then, substance consists of two types, namely hydrated substance and anhydrous substance. I think
Yes.
that's all, Mr.
Excellent, Windu. How great you are. Thank you, Windu. Okay. Well, the conclusion of our lesson today is, first one is, insoluble salts can be prepared by precipitation. And the second is, general solubility rule for salts describes about solubility characteristic of several kinds of salts, namely sodium, potassium, and ammonium, nitrates, chlorides, sulfates, carbonates, and hydroxide salts. And the third substance are of two types, namely hydrous substance, which is chemically combined with water, and anhydrous substance, which is containing no water. Okay, well, class, before I close it, I wanna give to you a motivation. So everything will be hard if you think it's hard, but everything will be easy if you think it's easy. Okay, thanks for paying attention. Well, class, because of the lesson is end, so we are going to do the quiz. Please close all of your books and then do it by yourself. No cheating, please. If you are got caught cheating by me, I promise that your score will be divided into two with your cheating partner. Okay, please wait. I'll share the link of quiz. Okay, please wait. Please wait, everybody. I did a Solonger. Please wait. So this is the link of the quiz. So okay, do it by yourself, no cheating, please, and finish it in 10 minutes. Go. Okay, class, time is up. Stop working and collect your work, please. Stop your working. Okay. Okay. Here. Okay. Well, have you seen your score? How about your score?
Alhamdulillah, Mister. My score is not bad.
Yes, it's
Not
easy.
bad, Mister.
Yes, good. Go ahead. Rosiani, how about your score? Okay. So congratulations on your achievement. Please maintain it for those of you who got the best score, and please learn more for those who have not got the best score. Okay. Yes. All right, class. It's time to end the lesson today. Thank you so much for your paying attention. Don't forget to collect your worksheet, and don't forget to learn the next material lesson. And stay at home and keep doing the health protocols. And before we close our lesson today, let's say a prayer together. Prayer begin. Okay, I think that's all. Thank you so much for one more for attention. Okay, see you next meet. Okay, I close it. Assalamualaikum warahmatullahi wabarakatuh. See you, class.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank
Thank
you
you,
so
Mister.
much, Mister. See you soon.
You're welcome.